Hey guys, Christian here, again with another quadratic question. These ones pop up all the time. So we're given a quadratic equation, right? Pretty ugly looking one, to be perfectly honest. M values everywhere. And it says find the value or values of M for which the quadratic equation has two solutions. Now, when you're dealing with quadratic problems, especially when you're interested in how many solutions, your best friend is this guy, right? The little triangle, whose formula is given by b squared minus 4ac. Whenever you're doing a quadratic problem and you're concerned with number of solutions, this is going to be your golden ticket, right? Basically speaking, if the discriminant is greater than 0, then you have two solutions. If it's equal to 0, you have one solution. And if it's less than 0, you have no solutions. No matter how ugly, weird, complicated or simple a quadratic problem is, this rule never fails. All you have to do is identify the correct values for A, B, and C, plug them into this formula, see what values turn out. Now, in a question like this, where it actually wants you to find the values for which the quadratic has two solutions, basically what you're going to do is you're going to sub everything in, and then you want it to be greater than 0. So you're going to solve for M so that whatever expression you've got is greater than 0. Now let's have a look at how we're going to approach this. We've got our values for A, B, and C. A is always the coefficient of x squared, B is always the coefficient of x, and C is always the constant value by itself. When we plug everything into this formula, we'd have B squared minus 4 times A times C. That's our discriminant. Let's simplify it down first, but then we're going to have a look at how to make it greater than 0 so that we get our two solutions. Now, when we expand this little square part, we have to remember that 5 minus 2m squared means 5 minus 2m times 5 minus 2m. So that's a perfect square or two sets of brackets. Just scribble them out next to each other and quickly expand it if you're not familiar with the perfect square formula. If you are, you can just go straight ahead. So you'd have 25 minus 2 times 5 is 10 times 2 is 20m plus 4m squared over 4 because the 2 gets squared as well. And then the second portion, we would have negative 4. Let's do this bit first. We'll have negative 4 times 2m, which is negative 8m, right? And then that times m would be negative 8m squared. And negative 8m times negative 1 would be plus 8m. So that's our discriminant. Not very pretty at the moment, but if we shrink it down a little bit, we'll have something we want to work with. Now, by putting those last two values as fractions over 4, we can combine the entire lot. But there is a quicker way to do it. It's a little bit of a cheeky way. What we're going to do is we're going to say, right, we want this to be greater than 0. Now, as long as we follow the rules of equations, anything you do to one side, you do to the other, you will be able to work through this. Instead of trying to put everything into a fraction, I'm just going to go ahead and eliminate all of the fractions. Now, I can do this because one side of the equation is equal to 0, which means no matter what I multiply by, 0 times whatever will be 0. In this case, I'm going to multiply both sides by 4. And what that's going to do is it's going to get rid of this ugly fraction on the left-hand side. So 25 minus 20m plus 4m squared. Since we've multiplied by 4, that 4 is no longer relevant. We've also multiplied these last two numbers by 4, so that would give us 32m squared and 32m. And it's still greater than 0 times 4, which is 0. All right, we've got something we can work with now, right? Put all your like terms together and try and shrink it down. So we've got 4m squared minus 32m squared is negative 28m squared. I just like putting the squared terms first because it fits the quadratic, which I'm very familiar with. Negative 20m plus 32m will give us plus 12m. And then we've got our plus 25 by itself, and we want that to be greater than 0. Now, this is where you start to get a little confused because this in itself is a quadratic problem, but it's a little bit simpler to work with. What we want now is we want to find what values of m would make this expression greater than 0. And if you can find that, you win. Now, this, we can see, a little bit of a quick graph can actually help you. This quadratic is a negative quadratic, which means it's a negative parabola. Now, I have no idea what it looks like, but I'm just going to assume it does something like this, right? Which means that this section and this section would be the negative portions. Those would be the portions that would be below 0. And we want the positive portion, the bit that's above 0. That's the bit that we actually want. So if we can figure out what its x-intercepts are, we can say that between those x-intercepts, the quadratic is positive. All right, so when m is between this x-intercept and this x-intercept, then the overall quadratic is positive, which means the original quadratic has two solutions. Is that making any sense? All right, so we're going to take the original quadratic, find the discriminant. When that is greater than 0, the original will have two solutions, and we just now work out what makes this quadratic greater than 0. We figured out that this quadratic is greater than 0 only between its two x-intercepts because it's a negative parabola. So if we can find those two x-intercepts, we're in the money. Now, believe it or not, the trick to finding those two x-intercepts is to use the quadratic formula again. That's the quickest and easiest way to do it. So this time we're going to have very specific values though because we've got all numbers. So we're going to say that m is equal to the quadratic formula, which is negative b plus or minus. Again, if you haven't got this formula memorized, you really need to because it's just too handy not to have. Now you're definitely going to need your calculator to process some of these numbers, and that's totally fine. Right, because the important part is you know what's going on. So I'm just going to quickly grab my calculator and I'm going to go 12 squared minus 4 times negative 28 times 25, which gives us 2,944. Cool. So negative 12 plus or minus the square root of 2,944 over negative 52. All right, if we take the square root of that number, it is around 54, but we probably don't need exact value, decimals. Exact values will do us in a pinch. So basically, anywhere that m is bigger than this x-intercept, which would be negative 12 minus the square root of, or this one, which would be plus. Actually, it'd be the other way around, because what would happen here is the negative 52 spins everything on its head. When you divide by a negative number, everything goes backwards. So this particular value would be 12 plus the square root of 2,944 over 52. And this would be 12, minus and 12 plus. There we go. Right, keep an eye on those negative signs, all right? They can get away from anybody. Be really careful that you've got everything lined up properly. The important part is if m is between these two values, right? Between these two values, but not equal to these values, because if it was equal to those values, then this quadratic would be equal to 0, which means that this quadratic would only have one solution. We want two solutions. So if m is a value that is somewhere between 12 minus the square root of 2,944 over 56, not 52, I was rewriting that, and 12 plus the square root of 2,944 over 56, then this quadratic would be greater than 0, which means that the original quadratic would have two solutions. All right, if you're a little bit iffy on this, go back and watch it. These questions are surprisingly common and they are surprisingly frustrating. Once you deal with them though, and you deal with them enough times, you start to spot the pattern and you'll start to repeat your procedure again and again and again. That's it for today, guys. I will see you on the next one.